Okay, we're going to move on to the last section, 11.7, circles touching the x or y axis. So if a circle touches the x or y axis, then the radius of the circle is equal to one of the coordinates of the center. Okay, so if we look here, a circle touching the x-axis, I think we've seen this before in questions. This radius must be the same as the y coordinate because it goes up the y amounts. And the same way with the circle touching the y-axis, this coordinate here must be the same as the radius. So the x coordinate must be the same as the radius. Now, where in these notes do they get this minus g and minus f? If you remember page 19 of your maths tables, this is one of the ways we can write a circle. And remember, the center is half of this one, change the sign, and half of this one. That's where the center comes from, minus g minus f. And there's the formula for the radius as well. Okay, again, that's on page 19. So what they say is that the radius from that formula is equal to minus f, the y value. And when you square both sides, they end up simplifying down to get g squared is equal to c. I'll zoom in a bit there. G squared is equal to c. And we're going to be using that in the question that we're going to try, so I'll show you why we're doing this. And then the second one, if the center is here and it's touching the y-axis, this distance here must be the x-coordinate, and in circles the center is minus g, so this radius equals minus g. Okay, and they use those symbols to mean what they're talking about. It has to be the positive because we're dealing with the length in terms of radius. So they square both sides, they get f on its own and c on its own, so c is equal to f squared. And again, you'd use that if you were talking about the y-axis. So what I want you to do first is take down those two with the diagrams and the proofs clearly shown, how you get g squared is equal to c and how you get f squared is equal to c. And what I'm going to go through is this one example. You can see it's quite long, but I'm going to try and talk through that, and hopefully it'll be a bit clearer by the time we've finished. Okay, so first things first, read the question. So the question says, find the equations of two circles containing the points 3 minus 2 and 2 minus 1. So 3 minus 2 and 2 minus 1. So the first thing I'm going to do is a little sketch, and they've done that over there. So I'm going to do a sketch over here. And it says it touches the x-axis, so this is the x-axis. So I'm just going to plot those 2 points. We'll just say that's 2, 1. 2 minus 1. And this point here, down here, is over here, 3 minus 2. Okay, and we just draw a circle that touches the x-axis but goes through both of those points. And the center is minus g minus f. And that's obviously the radius, the distance from the edge here. Okay, so that diagram's given to you on page 450. Again, if you didn't have the diagram, you'd have to sketch it out. Now, it says two circles. The circle could also be a circle that goes here, a circle that went through them that way. Okay, so it says two different circles. Right, so from your maths tables, the equation of a circle is there. So I'm going to write out that equation. X squared plus y squared plus 2gx plus 2fy plus c equals 0. That's the equation of a circle. And what I'm going to do is I'm going to substitute in my x and y values into that equation. Okay, I'm going to substitute in my 2 in and my minus 1, and then separately then I'm going to substitute in my 3 and my minus 2. And that's what they do first. So the first one they do is 2 minus 1. So it's 2 squared plus minus 1 squared plus 2g times 2 plus 2f times minus 1 plus c is equal to 0. And when we rearrange that and not solve it but simplify it, 4g minus 2f equals 4 and 1, 5, bring it across, minus 5. That's my first equation. Oh, sorry, I've left something out there. I've left out the c. Plus c equals minus 5, and that's my first equation. Then I do exactly the same for 3 minus 2. So 3 squared plus minus 2 squared plus 2g times 3 plus 2f times minus 2 plus c equals 0. And when I simplify that, I get 6g minus 4f plus c, and that's 9 and 4, 13 equals minus 13. And that's 2. And now going back to what we looked at in the previous page, this is where we're going to use this. I've got 3 unknowns here, but I only have 2 equations. Okay, usually remember simultaneous equations we did in 4th year and the start of this year. When you have 3, you'd need 3 equations. So we come up with another equation, and the other equation we're going to come up with is one of the ones from the previous page. So the radius, this distance, is equal to the y value. Okay? So the radius is equal to this value, the minus f. So what we say is the radius, g squared plus f squared minus c, is equal to the minus f. Square both sides, we get g squared plus f squared minus c is equal to f squared. The f squareds will cancel, and you're left with g squared minus c is equal to 0. So from that, c is equal to g squared. And that's a third equation that we're going to use. Okay, so we're going to move on. And again, I'll sort of pull this over so we can see both sides. Okay, remember, pause this at any stage to take that stuff down. Right, so go there, be able to write now. Okay, so what I want to do is, I want to look at these 2 first, and I want to get rid of the f. Okay, I'm going to get rid of the f. Now, just to save space, I'm not going to write them out and multiply. So if I was looking at these 2 and I want to get rid of the f, this one and this one. This is a minus 2f, this is a minus 4f. I'd multiply this one by minus 2. Again, some people multiply it by 2 and take away, that's absolutely fine. So it's going to be minus 8g plus 4f minus 2c equals 10. That's number 1. And my second one stays the same. 6g minus 4f plus c equals minus 13. That's number 2. I would add them, and I'd end up with minus 2g. Those would cancel. Minus c equals minus 3, and that's what they have in the book. And then I get c on its own. C is equal to minus 2g plus 3. Okay, now the reason I've got rid of the f is because now I've got g, or c in terms of g, and we have this third equation. So instead of c, I'm going to substitute in g squared. So instead of c, I'm going to substitute in g squared. So it now becomes minus 2g plus 3 equals g squared. Bring everything to one side. G squared, bring this across. 2g minus 3 equals 0. I'll solve for g. G equals 0. It has to be 3 and 1. It has to be a plus, so plus 3 minus 1. So g is equal to 1, or g is equal to minus 3. I'm just going to put a little note in here again. So that's all I've done to replace it there. I'm just going to check I'm gone right. Yeah. Okay, and then what I'm going to do is, from that, I can now find out what c is. Okay, we found out what g is. I'm going to find out what c is. So when g is equal to 1, I'm going to go back to, just make sure we use the same one as them. Minus 2 times 1 plus minus c equals minus 3. So c is equal to minus 2 minus 3. Minus 2 plus 3, c is equal to 1. And then when I do g is equal to the other answer, minus 3, we get minus 2 times minus 3 minus c equals minus 3. So c is equal to, this becomes 6, 9. Okay, so we found out, I'll actually put it C, C, G, G. And then we obviously have to find out our y's. Okay, so I'm just going to clear a bit of room for myself. Just going on to third page. And we obviously pick one of the first two equations. Okay, so we're going to pick either this one or this one. Okay, I'm going to pick the same one that's in the book, just so you're able to look at both solutions. So they pick the 4g one, the one that starts equation 1. So I'm going to write out that 4g minus 2f plus c equals minus 5. That was our first equation. And now when g is equal to 1 and c is equal to 1 also. Okay, when I substitute in g is equal to 1, c works out to be 1. So it's going to be 4 times 1 minus 2f plus 1 equals minus 5. 2f is equal to 4 plus 1 is 5 plus 5 is 10. So f works out to be 5. And when I substitute in g is equal to minus 3 and c is equal to 9, I'm going to get 4 times minus 3 minus 2f plus 9 is equal to minus 5. So I bring the 2f over here, equals minus 12 plus 9 minus 3 plus that 8. So f works out to be 4. Did I make a mistake there? I think I did. Just 1 second. So minus 12. Yeah. So that becomes minus 12 minus 3 minus 3 plus 5. That actually works out to be minus 2. Just 1 second. Sorry, I confused myself there. That works out to be 2. So f works out to be 1. Okay. Minus 12 plus 9 is minus 3 plus 5 is 2. Brain wasn't working there a sec. F is equal to 1. Okay, so you have your 6 answers, and the reason you needed 6 answers is because you've got 2 circles. Okay, one circle has a G, F and C in it, the other circle has a G, F and C. So the 2 circles, circle 1 has a G, F and C, and the G, F and C is 1, 1 and 5, and then for circle 2 it's minus 3, 9 and 1. So just be careful. So circle 1, and I might just write out, I might just write out the formula again. X squared plus y squared plus 2gx plus 2fy plus c equals 0. So circle 1, for my g, I'm substituting in 1. So it's x squared plus y squared plus 2 times 1 is 2, so 2x. F in this case is 5, so it's plus 10y, and c in this case is 1. I'm getting these from all up here. Okay, plus 1. And then circle 2. It's going to be x squared plus y squared. Be careful here. G. Okay, my g in this case is minus 3, so minus 3 times 2 is minus 6x. My f is 1, so plus 2 times y, and then finally my c is 9, plus 9 equals 0. And again, I'll just check those in the book. We have x squared plus y squared plus 2x plus 10y plus 1 equals 0, and x squared plus y squared minus 6x plus 2y plus 9 equals 0. Okay, so as you can see, quite a long example. There it is in all one go if you want to pause it there and take a picture. And And I'm going to give you 2 questions like that to try. Okay, and there might be some shortcuts depending on the numbers they give you, especially if there's zeros involved. Alright, any questions, please comment.